This video is in answer to a challenge to explain how the internal combustion engine works in terms a non-mechanical person can understand. The objective of an engine is simply to create a spinning motion. And what better way to do that than just to spin it or crank it around using a crank, or in this case, a crankshaft. Think of the crankshaft that connects the pedals on a bicycle, which connects to the frame with a set of bearings that allows it to spin. On an engine, these would be called the main bearings, and the frame that the crank connects to would be the crankcase, or engine block, or just block for short. On an engine, however, the crank would connect to the crankcase on both sides of where the pedal would be attached, the area known as the rod bearing journal. Two pedals would be the equivalent of a two-cylinder engine, often called a twin, although engines come in a wide variety of number of cylinders, from one single cylinder to as many as 16 in some cars, with a varying number of main bearings. So what does the cranking to create this spinning motion? Well, essentially, cannons. Take a tube or cylinder, put in a round object that just fits, called a piston in this case, fill one end of the cylinder with a flammable or explosive substance, such as gasoline or diesel fuel or whatever, then ignite it or light it up. The explosion then forces the piston down the cylinder. Some engines will run on almost anything that burns. The piston is then connected to the crankshaft with a rod, called a connecting rod, at the rod bearing journal, which pushes the crank down. And just like on a bicycle, when the crank reaches the bottom, it swings back around and pushes the piston back up the cylinder for another go. And we've got our spinning motion. The cylinders vary in size, in both how big around they are, called the bore, and how long they are, or how far the piston can move inside of it, called the stroke. Cylinder size and number of cylinders determine the size of the engine, measured in volume, such as liters, cubic centimeters, or cubic inches. Most road-going cars, and all modern ones, have what is called a four-stroke or four-cycle engine, which is to say the piston moves through the cylinder 4 times per cycle, down twice and up twice. With the first stroke, a valve opens at the top of the cylinder, and the withdrawing piston sucks in the fuel, similar to the way a hypodermic needle works. This is called the intake stroke, as it takes in fuel. On the second stroke, the valves are closed and the piston moves back up, squeezing and pressurizing the fuel. This is called the compression stroke. Then the compressed fuel is ignited by a spark, created by running a jolt of electricity through a spark plug mounted at the end of the cylinder, causing the explosion that gives the engine its power, pushing the piston down the cylinder. This is called the ignition stroke or the power stroke. Then it goes back up, another valve opens up allowing the piston to push out the burnt fuel as exhaust in the exhaust stroke. Then it repeats, making the 4 strokes intake, compression, ignition, exhaust. Or a simpler way to remember it would be suck, squeeze, bang, blow. A process that is started by using a small electric motor to create the first few spins. This electric motor that starts the process is called the starter. The top of the cylinder, where the spark plug is covered by what is called the head, simply indicating the top of the engine. There is a seal between the head and the main engine block, called the head gasket, and this seal is important both to keep the cylinder from losing pressure and to keep other things out of the cylinder, such as coolant. And of course, all these moving parts need to do their thing at the proper time, requiring timing. This, of course, is called engine timing. This is primarily controlled by the camshaft, a shaft that spins from a connection to the crankshaft, usually with gears, the timing gears, and sometimes a chain or belt, called the timing chain or timing belt. Naturally, the camshaft has cams, or lobes, or lumps. It's the same basic concept as the shaft or the drum used on a music box. Not only does the position of the lobe determine when the valve opens, The size and shape controls how far they open and how long they stay open. The position of the camshaft, or just cam, and the valves can vary, creating a number of different engine configurations, such as side valve, overhead valve, or overhead cam, indicating that the valves and or cam are either on the side of the engine or on the top of the engine above the head, which may also involve a number of other parts to connect the cam and the valves, such as lifters, push rods, rocker arms, all depending on where they are located in the engine and how far apart they are. The camshaft is also connected to another shaft that distributes the electricity to each spark plug in turn, called the distributor. A fuel delivery system, or induction system, is also needed, or more accurately, a system that mixes the liquid fuel with air to make a vapor that will easily burst into flames. Today, this is typically done via some sort of fuel injection. There are a variety of types, but ultimately they are not much more than a squirt gun, or a group of squirt guns. But older cars used carburetors instead, which is more like an overcomplicated toilet. You pull the lever and the fuel goes down. It even has a tank and a bowl, although the tank is called the bowl and the bowl is called a barrel or port. The fuel is then fed to each cylinder through a group of pipes, called an intake manifold. Once the fuel is burned, it exits through a similar group of pipes, making up the exhaust manifold, which then comes together into an exhaust pipe or two, allowing the smoke to exit. Naturally, all of these moving parts create a lot of heat and friction and must be lubricated. So the bottom of the crankcase or engine block is filled with oil in what is called the oil pan. This oil is pumped through the engine to be sprayed on the moving parts with an oil pump. There is also a water pump that pumps water through lines inside the engine block to help keep it cool. And these two systems must be kept separate, as oil and water do not mix. And when they do, it means bad things for your engine. And failure of any part of the engine can prevent it from running. Has this been an oversimplification? Absolutely. But that's kind of the point. This video isn't intended to make you a mechanic overnight. And there are much more accurate and in-depth videos out there for those who are interested. But for those that see what happens under the hood as being just this side of magic, hopefully this video will add just a little bit of clarity. As always, thanks for watching. Don't forget to comment below and like and subscribe.